Day 4 video lecture, we're going to start with a 60-second question. For the following list of inputs and outputs, find the rule that will take the input to the output. Okay, so we have a list of inputs here that are being sent to an output. And what is the quote-unquote rule that is making that happen? So pause and think about that, and then unpause when you are done writing. Okay, so you may think, well, when you look at 1 and 3, you may think something like, okay, 1 times 3 is 3, so maybe we're multiplying these by 3. Oh, and 2 times 3 is 6, so that's working. But then 3 times 3 is not 11. 3 times 3 is 9, right? So that rule doesn't work. And then maybe you think, oh, maybe f is 6. F of 3 is 11. And remember that, sometimes we talk about inputs and outputs as x and y, but when we're using this type of notation, we would say x and f of x. Okay, so what about the inverse? See if you can remember what it means to have an inverse function based on your Algebra 2 knowledge, right? So we know that x squared plus 2 takes the input to the output. So what could be the rule that takes the output back to the input? Well, that's just the exact inverse function, right? So if we want to figure out how to send y to x, we could maybe call this like a function f of y, right? I want to plug in a y value and send it back to the x value, right? So it ends up being the square root of y minus 2, right? That's the inverse operation that's going to send this output back to the input. So if we do, for example, f of 3, this means we're plugging in y equals 3, and that gives me square root 3 minus 2, which equals square root 1, which is 1. So this is the rule that sends output 3 back to input 1. And we're not going to use this f of y notation. I'll show some better notation that we will use when we're talking about inverses. Okay, so the function f of x sends the inputs to the outputs. The function f of y sends those outputs back to the inputs. We call these inverses of each other. But what we're normally going to do is we're going to say f of x equals x squared plus 2. And then we'll define the inverse function f inverse of x. So we'll put this negative 1 kind of up in this exponent area, f inverse of x. And that's going to be equal to square root of x minus 2. And these two functions are inverses of each other. So this is the notation we'll normally use. Okay, so what ends up happening when you have a function and inverse function is that the outputs and the inputs get flipped. So the inputs of this function are actually the outputs of the inverse, and the outputs of this function are actually the inputs of the inverse. Okay, so the inputs and the outputs get flipped. We want to think about why that makes sense. Okay, function sends inputs to outputs, inverse sends outputs back to inputs. So function sends 1 to 3, inverse sends 3 back to 1. Function sends 2 to 6, inverse sends 6 back to 2. They're flipped. So I want to unpack that a little bit more. So if I have a function f of x equals 3 times the square root of x minus 5 plus 7, these are the operations that are happening to my input x, and this is the order in which they happen. So this is an order of operations thing. X, what happens to x first? Well, first we subtract 5 from x, and then we square root whatever we get, and then we multiply by 3, and then we add 7, right? So let's look at f of 9 equals 13. 9 is our input. First thing we're doing to 9 is we're subtracting 5, and that gives us 4, right? So 9 minus 5 is 4. And then we're going to take that 4 and we're going to square root it, which gives us 2, right? So square root of 4 is 2. Then we're going to take that 2 and we're going to multiply it by 3, which is just going to give us 6. So next 2 goes to 6. And then we're going to take that 6 and we're going to add 7, which gives us 13. So 6 becomes 13. So this is like the journey that input 9 goes through to become output 13. So if we're going to do an inverse, then we have to undo all those operations in reverse order so that we can take 13 back to 9, right? So let's look at these inverse operations in reverse order. So the last thing we did in the original function was add 7. So that's going to be the first thing we undo in the inverse. We're going to subtract 7. Instead of multiplying by 3, we're going to divide by 3. Instead of square rooting, we're going to square. And instead of subtracting 5, we're going to add 5, right? And we're undoing it in reverse order so that we can take that output and take it all the way back to the input that we started with, right? So let's look at 13. Okay, we're going to do 13 minus 7, which gives us 6. We're going to do 6 divided by 3, which gives us 2. We're going to do 2 squared, which gives us 4. And then we're going to do 4 plus 5, which gives us 9. So the original input went from 9 to 4, 4 to 2, 2 to 6, 6 to 13, right? The output to go backwards is now going to go 13 to 6, 6 to 2, 2 to 4, and then 4 back to 9, right? All of this just happens in reverse order. So then I already have this written here, but this is how I would write this inverse. Once I have this list of inverse operations in the order they happen in, I'm just going to start with an x, right? That's my input. What's my first thing I'm going to do to x? I'm going to subtract 7, because the last thing I did before was add 7, okay? And then I'm going to divide by 3. So I'm just going to divide the whole thing by 3. Then I'm going to square the whole thing, because the next thing that I do is square, and then I'm going to add 5. Okay, and this is the inverse function of f that's going to send the outputs of f back to the inputs. Okay? So you try one. Let's try to find the inverse of this function f of x equals x plus 2 squared over 5 minus 7. Please pause the video and work through it. Okay, if you're unpausing, that means that you've already attempted this problem. So when I do this, what I'm going to do is I'm going to list out the things happening to input x. So the first thing that happens is I add 2, right? X plus 2. Then after I add 2, I square the whole thing. So I'm just going to do parentheses squared. Then I divide by 5, and then I subtract 7. And that happens in this order. Okay? So then what am I going to do for f inverse? I'm going to undo all of these things, right? So the inverse operation of minus 7 is plus 7. Inverse operation of divided by 5 is multiply by 5. Inverse operation of squaring is taking a square root, and the inverse operation of plus 2 is subtracting 2. And these are going to happen in this order. So then, if I take f inverse of x, I'm going to start with x. Okay, the first thing that happens to x is I add 7. Then I have to multiply that whole thing by 5. Then I have to square root the whole thing, and then I have to subtract 2. Again, just following this order. This is my inverse function now that is going to undo this function. It's going to send the outputs of this function back to their inputs. Okay, so let's try f inverse of negative 2. That's equal to square roots of 5 times negative 2 plus 7 minus 2, which is equal to square root of 5 times 5 minus 2. Okay, the square root of 5 squared is just 5 minus 2, which equals 3. So f inverse of negative 2 is 3. So what does that tell me? What does it tell me about what f of 3 is? F of 3 should be negative 2. Because if the inverse sends negative 2 to 3, then the function has to send 3 to 2, or to negative 2. They're reversed. Okay? So one more thing I want to show you is we can compose these two functions and see what happens. What I want to do is I want to do f of f inverse of x. I'm going to plug the inverse into the function, which means that I'm going to replace x. I'm going to replace x with the entire inverse function. So the inverse function's down here. I'm going to plug that in. Okay, so I'm just going to do that really quick here. We're going to have to leave a little bit more space to fit this, so I'm going to move my parenthesis sign over. Hopefully that's enough. Okay, so all I've done is I've taken x from the x plus 2, and I've replaced it with the inverse function. Okay, so I have x is replaced by square root 5 times x plus 7 minus 2. So let's look at what happens. Well, minus 2 plus 2 is just equal to 0, right? So then that leaves us with square root 5 times x plus 7 squared over 5 minus 7, right? Well, what's going to happen with the square root and the square? Those are also going to cancel. So then we have 5 times x plus 7 divided by 5 minus 7. Okay, well, what happens with the 5 and the 5? Okay, 5 in numerator and denominator cancel. So now we just have x plus 7 minus 7, and that equals x, right? This makes sense because the inverse and the function undo each other. They undo all of their operations. So if we start with x, then we should just end with x if we're using the inverse and the function together, right? All of the operations are undone, they cancel each other out, and we're just left with x. Okay, here are 3 inverses to try and then 1 optional challenge. So these are 3 practice problems. Just pause and work through them, and then pause and work through them, and then unpause to see answers. So I have the first 2 answers up. We have 2 times x plus 5, note the parentheses, and then x over 3 cubed plus 2. For this third one, I'm going to actually work through it step by step for you. So we look at x. The first thing that happens is we square x, right? It's at 2x squared. The next thing we do is we multiply by 2, subtract 3, square root, and divide by 7. Okay, I'm going to move this. I had one flipped actually too. We square it first, we multiply by 2, subtract 3, divide by 7, last thing we do is square root, right? So this is the function. The inverse is going to be all of that in reverse order. So we square it first, multiply by 7, add 3, divide by 2, and then square root. Okay? So then that happens in this order. So f inverse x is equal to x squared times 7 plus 3 divided by 2, and then finally take a square root. Okay, remember, again, following this order. X squared times 7 plus 3 divided by 2, and then square root the whole thing. This is the inverse of this function. For time purposes, I'm not going to do the optional challenge, so if you want to check your answer on that, you're going to have to email me. Okay, so now, what if we have a table here, right? So if I say f inverse of negative 2, g inverse of 13, right, g inverse of 10, what does this mean? Well, remember, inverses send outputs back to inputs. So what we should do is we should label these as outputs, right? These are the outputs of f, and these are the outputs of g. So if I say f inverse of negative 2, what I'm going to do is I'm going to find f of x outputs, I'm going to go down to negative 2, and I'm going to see the input that goes with it. F inverse of negative 2 is just 2. Okay. G inverse of 13. Okay, so I'm going to go to the outputs of G. I'm going to look for 13, and I'm going to see the input it goes with. Okay, input that goes with 13 is 3. So G inverse of 13 is just 3. Okay. Now we have to do f of G inverse of 10. So this is a composition. We have to do the inside first. What's G inverse of 10? It's 1. So we're going to say, well, then what is f of 1? Okay. Do you see an inverse sign here? No inverse sign, right? This is just the function f. The function f sends inputs to outputs. So now we have to go to the inputs x, find f of 1, and we see that it's equal to negative 5. So this final answer is going to be negative 5. Here's a few to try. You can pause and do them yourself, or just listen to me do them now. So again, with the composition, we have to do the inside first. Do you see an inverse right here? Nope. So it's just the normal function g. So we're going to go to the input 1 and see what g is equal to. It's 10. So now we need to do f inverse of 10 minus 9, which is going to be f inverse of 1. So now we need to go to function f, and it's an inverse, right? So we have to go to the outputs, and f inverse of 1 is equal to 3. So f inverse 1, 3. Okay. So that's our final answer for this first one. Okay. F of 2. Do you see an inverse? No inverse, so that means that we're going to go to input 2, and that goes with output negative 2. What's negative 2 plus 5? That's going to be 3, so we're looking for g of 3. Not inverse, it's just g of, so we're going to go to input 3, and that goes to output 13. So g of 3 is equal to 13. Okay, final answer there. Okay, and finally, we have g inverse of 12. G inverse of 12. So output 12 goes to input 2. So that means we have f of 2 minus 1, which is just going to be f of 1. And then this is not inverse, this is normal f, so we're going to go to input 1 goes with output negative 5. So then we have this is equal to negative 5. All right, that is all for today.